Hello, this is Dr. Henry, and today we're going to be looking at percent yield. And by yield, we don't mean like what you do when you see a sign on the highway and you try to speed up so you can get in front of everybody when merging on into traffic. But yield means how much do you make? All right, so we're going to be looking at chemical reactions. If you start with a certain amount of products, if you start with a certain amount of reactants, how much product will you get? And what we have been doing with all our stoichiometry problems, when we've been starting with grams of reactant and we've been trying to find grams of a product, we've already been calculating theoretical yield. And that's the maximum amount of product that can be made or produced from a given amount of reactant. And that is calculated. It's a problem. We do that on paper. Now, when you actually do reactions in the lab and you measure the amount of a product that you get, that's called an actual yield, and that's done in the lab. And what we're going to see in our practice problems today is that in these problems, you will be given the actual yield just so you can get some practice calculating percent yield. But normally, actual yield can only be gotten by doing it in the lab. And here's the formula. So you will take the actual yield divided by the theoretical yield times 100%. That gives you the percent yield. And the reason this is important because it can tell you how efficient a reaction is. And if you're doing a reaction to get a product and those reactants are costing you money, then you want to know how well your reaction is working. Is there something you can do to improve it? Is there some way that you can get more bang for your buck, basically? And so let's look at a problem. So suppose you have a reaction. You have 2 moles of aluminum plus 3 moles of copper chloride produces 2 moles of aluminum chloride plus 3 moles of copper. And I can already see there's one mistake here. Just ignore this. So let's suppose you had 9 grams of aluminum and an excess amount of copper 2 chloride. You recovered 28 grams of copper in the reaction, and you want to know what your percent yield is. So they give us that we're recovering 28 grams of copper. So this is our actual yield. All right, so we're doing this problem. They've given us the actual yield. We want to know percent yield. So we've got to figure out the theoretical yield. So we're looking for the theoretical yield of copper. Now, for every 2 moles of aluminum, we need 3 moles of copper chloride for this reaction to occur. So when we say we have an excess amount of copper 2 chloride, well, then what that means is we may have like 4 moles of copper chloride, or 5, or 6. We just know that we have enough copper chloride for all of the aluminum to react. All right? So we're ignoring the copper chloride, and we're just going to do a stoichiometry problem that's going to convert 9 grams of aluminum to grams of copper. So we are given 9 grams of aluminum. So we need to go from grams of aluminum to 1 mole to moles of aluminum. We know that in 1 mole of aluminum there are 26.98 grams. All right, now we need to go from moles of aluminum to moles of wanted, which in this case is moles of copper. And looking at the balanced chemical equation, we know for every 2 moles of aluminum, we have 3 moles of copper. All right, now we want to go from moles of copper to grams of copper, and we know by looking at the periodic table in 1 mole of copper there is 63.55 grams of copper. And this is a gram to gram stoichiometry problem, just like we've been doing for the last few days. So multiply everything on top, divide by the bottom, and we end up with a theoretical yield of 32 grams of copper. So we've done this before, except now we're just calling our answer theoretical yield. And so the second thing we need to do is we need to find the percent yield. and that is the actual yield divided by the theoretical yield times 100. So we were given that the actual yield was 28. We did the stoichiometry problem. The theoretical yield is 32 grams of copper. So we have 28 divided by 32 times 100% equals 88%. That's our percent yield. And it's time for this class to start. So I'm going to pause this and stop it right here. That's the end of our notes on percent yield.